This is video 56 on a MicroPython embedded solution. Building MicroPython with LVGL for ESP32 boards using standard instructions is a bit complicated. We wondered if another approach could make it easier. In this video, we learn how to use Docker to build ESP32 firmware. Please let us know in the comments about your experience. We welcome ideas and suggestions. For this effort, we assume you have Docker installed. Our test rig is just to flash the firmware to an ESP32-S3 USB board and start it in Thony. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal is to create a MicroPython build environment using Docker. We will demonstrate the firmware in Thony, discuss the source and software prerequisites, review the build approach, and walk through the build. The Docker file and the firmware files are at the GitHub site that is mentioned in the description and endnotes for this video. Let's verify the firmware. We shall SFTP connect to our Windows desktop. Let's log in. Let's change the directory on our desktop. All right, let's push the file there. Okay, let's see if we can connect. All right, we've inserted the USB cable to our ESP32 USB board. We're going to select the COM port. We can configure it using the Thony options. It brings up a dialog. Select the Install or Update MicroPython ESP tool. It brings up a new dialog. On the smaller dialog, we want to press the 3 slashes in the lower right-hand corner. It looks like a hamburger symbol. That brings up another dialog, so which we can select the MicroPython image. You can't really see it, but I'm just navigating to the folder 56. Now you see it's brought in that firmware, and we can set the target port. Now click on the install button to flash it. Okay, it's done flashing. Now we can close all these dialogues. Now, press the red stop button on the Thony toolbar. When you do, it does a soft reboot, and we can see the welcome message from the newly flashed USB board. You can see it's flashed with today's MicroPython, built the 25th. Let's take a look at the modules. All right, let's move around so you can see all the modules, and you can see the most important one is LVGL right here. So that shows that we have built MicroPython with LVGL or ESP32. Now that we saw it work, let's look at the steps. Essentially, our source is the two main LVGL kits for MicroPython and the Express if IDF kit. We also need some prerequisite software as a few extras that we will see in a few minutes. Our development platform is an old Ubuntu server to which we installed Docker. We are going to SSH from our Windows desktop to it, but we could just as easily use the virtual machine in VirtualBox or WSL2 on Windows Pro. Our test rig, as you saw, was just the Thony application. We used it to flash the firmware and connect to verify it works. Our build approach is to create a Docker file, build it into the BLD ESP32 Docker image, and then start an interactive Docker container to build the firmware. Building the Docker image is a one-time event that is time-consuming. The build will pull the base image, install the various prerequisites, and pull the source files. This effort took 50 minutes on my server, so we will speed it up a bit. When it's done, you have an image. We can invoke another Docker command to start it in a Docker container. Later, we found we started several containers. Using the first container, we restarted it interactively. Here are the 3 commands to build the firmware for an ESP32-S3 octal, that is, a USB board with 8 megabytes PS RAM. The firmware is built in a special folder. Here is the firmware file. Let's save the information from the build. Well, that's it. Here is a summary of the Docker commands we use. First, we have a Docker build that builds the image. We can list the images on our server. Next, we can create a container and connect to it using bash to interact inside the container. We can list containers on our server. We can restart a container and interact with it. You may have noticed that the images get rather large. Here is a Docker command to clean them. Additionally, while building the image, we cleaned up after the installs with this command. In summary, in this video, we discussed the MicroPython source and prerequisites. We presented the Docker approach. We walked through the build, image, install, and the firmware build in the container, and we verified the firmware. The benefit is an improved way to create the development environment and an easy build of the firmware. Please comment if you feel other changes are needed. I hope this video helps your MicroPython LVGL programming. Thank you for listening.